All right, now that we've learned how to solve a linear programming question by using the simplex method and how to optimize the objective function, let's talk about a bit more about constraint. So a constraint, usually it looks like this, is called binding at an optimal solution if a x0 plus b y0 plus c z0 plus whatever variables you have is not only less or equal, it is actually equal to k. Otherwise, the constraint is called non-binding. If a constraint comes from the availability of a resource, then this constraint is binding when the resource is completely used, right? You had k man-hour or k liters of milk, and you used exactly k to get the most out of your objective function. All right, so in the last example, we maximize the function p equals 2x plus y under all of these restrictions. Recall that we found that the optimal tableau was this. I want to find all binding constraints. All right, so what we had was these are basic, and we'd found that x is 7 by using the row of the leading one in x, and that y was 8 by using the row of the leading one of y. All right, so let's compute them all. So y equals 8. That's the first constraint. That's strictly less than 10, so it is a non-binding constraint. Let's look at the second constraint. That one was, yes, x plus y. In this case, that's 7 plus 8. That's 15. It had to be less or equal to 15. It is actually equal to 15. And so this one is binding. So the second constraint is binding. The third constraint was that 4x plus y, which in our case, that'd be 4 times 7 plus 8. That's 28 plus 8. That's 36. Yes, this one is binding as well. All right, so the binding constraints are the second and the third. So is x plus y less equal to 15 and 4x plus y less equal to 36. Let's look a bit more at this so that we could find an algebraic way of getting this that doesn't involve re-looking at each constraint equation separately. Here, S1, that is equal to 2. It's a basic variable. And notice that 2 is how much is left over. That's how much, how far I am from the maximum value of 10. Now, S2 and F3 were 0 because they're non-basic, and so we automatically put them to 0. And that's how far you are here and how far you are here. So notice that here, this is really another way of saying that S2 is 0. And here, this is another way of saying that S3 is 0. And so we've learned that a constraint is binding an optimal solution exactly when its slack variable is 0.